As I mentioned in the beginning, this third part of the seminar is based on applications of hydrogen, which have relevance into the setting of an island. Okay? So the first speaker of today will be Marc Lavine. Marc will be talking about the Sunrhyse project, which is based in the south of France. And he will talk about linking hydrogen production with distribution with potential uses in board settings as well. So, Marc, you can share your screen now.
I think it is, no?
Okay, so we can.
There, is that working? Okay, great. So you can hear me, thumbs up? Perfect. Okay, great. Well, I wish I could have been with you guys today. It seems like you're doing some great things there on the island, but it wasn't possible. So I'm glad at least I can join in remotely. Won't be able to be available at the end for sessions for Q&A. So I think the way that we've discussed this is I'll try and keep the presentation to 15 minutes, and then we can do 5 minutes of question and answer at the end of the presentation. Maybe a bit more, because I think it's more interesting to be more interactive as all of these projects are evolving. So I want to talk to you today about Sunrhyse, our green hydrogen production facility, but most importantly, focus in on how we're delivering and how we're using this for energy in a maritime sense. So first, a bit about Sunrhyse. Sunrhyse is located near Toulon, which is in the Côte d'Azur in the south of France. It's somewhere between Marseille and Monaco. And I say Marseille and Monaco because that's sort of our delivery range of where we can be producing and delivering hydrogen in a cost-effective way. The site itself is with solar energy. We're not doing our own solar panels. We're buying solar energy from a partner where we have a park to ourselves, which allows us to be able to put into the grid the equivalent of 24/7, so we can run our electrolyzers 24/7. We then compress on site, and then we transport out and to distribution facilities along the Côte d'Azur. We're going for terrestrial applications, but really focusing, as you'll see later in the presentation, on a much more maritime sector and approach on that. Again, Po introduced this as saying sort of things that we can do on hydrogen on islands, which I know is the focus of what we're talking about today in your conference. Sunrhyse is great. It's located in the south of France. It makes it easy for us to start because we're sort of on the continent. But the ecosystem that we're going to be talking about today is actually better adapted to places that are remote. We're looking at sites on Corsica and sites on different islands that are non-connected. I think it's even more powerful what we're providing in green energy solutions and green transportation solutions via hydrogen when you're dealing with locations that don't have access to a grid or access to green energy. In places that are more remote, especially things like Corsica, what we're talking about, is where everything comes from 80–90% of their energy is coming from burning gas and fuel. It makes even more sense of what we're trying to accomplish. So Sunrhyse is our first location that we're doing, and we're looking to do the same kind of ecosystem in remote locations and islands. Just a quick slide of using presentations of all the people involved. What's interesting is not just a production site where we're at the center of, but a huge amount of partners, and I think even energy observers talking today, or maybe you've already heard from them today, who's part of the partnership group, and they're really providing solutions as well. So there's a lot of people that make this a lot of sense, is starting with green production, but really focusing on developing quickly many usages for that green hydrogen throughout the ecosystem. So the Sunrhyse site itself is on the Plateau des Cygnes. It's done with electrolyzers. We don't have solar panels on site, as I mentioned. We're buying the green energy in a direct purchase agreement, but we'll be putting containers one by one, starting at 2 megawatts. At 5 megawatts, which is 2,000 kilograms per day. And we have the capacity on the site to scale up to 2 tons per day of hydrogen production. talk a bit about the ecosystem and where we're delivering. Again, this is along the coast, but you can imagine how this can be as powerful in a maritime setting. So we're producing inshore. It's about 35 kilometers from the coast of Toulon, and we're going to be delivering to many different locations and ports. Our real first-term applications, which we're seeing, is some sort of light mobility, but we're really focusing on providing energy for ports and for mobility in ports. I'll talk a bit more about that, and also for electricity, remote electricity for ships and other utilization. So as an example, our closest port is in Toulon, the port of Toulon in the air, which is just below our location. And there we're already working with a very series of different projects in the port, which go from light mobility for the vehicles around the port to, with Gosan, we have tractors that can actually be used to onboard and offboard trailers onto the boats. And one of the first and larger solutions, as you'll see on the bottom with the ferries, and I'm going to talk a bit more about that, is being able to produce energy for the ferries when they come into dockside. Today, as everyone well knows, when the ships come into port, they continue to turn their motors, not for propulsion, but for energy needs for the air conditioning and the hotel services. For a ferry like Corsica Ferries coming in, it's a passenger / transportation for trucks and for vehicles. It uses 1 megawatt of power per hour. That's something that cannot be done in Toulon with cables. They don't have the energy, and to provide that energy needs would be costly and timely. What we're being able to do is provide electrical generation, I'll talk a bit more about that, directly to the boats and providing instant energy with no infrastructure solutions. And that's one project that's starting as soon as we get up and running this summer. So talk a bit more in detail about the delivery and then talk about specific solutions. So as I mentioned, where production is done by electrolysis on site. We have various different sizes of electrolysis containers starting at 2 megawatts each. As I mentioned, we're starting with 5 megawatts, and we have the capacity as demand is being built to scale up to 12 tons a day. That's 35 megawatts. We then compress on site. This is really important, and we're compressing up to 450 bar. We're actually even looking now with some new advancements of compressing even further. We're hearing some pods that we can actually be done at 700 bar. The reason we're doing this compression to this level is it allows us to transport much more effectively at 450 bar. For now, and where the authorizations are going to change, but we can transport on any type of standardized containers at 450 to 500 bar on roads in France and throughout Europe. So this allows us to transport much more effectively to the customer. It also allows us to do compression filling on site, so we can do a lot of solutions in the short term that we actually, at 350 bar, where we actually don't need a local compressor. And where there are solutions where we need to be filling smaller trucks or cars at 700 bar, we can put in a mini station or being behind distribution stations where there's actual compression. But by producing and compressing to 450 bar, it really gives us a lot of flexibility in terms of delivery, in terms of the economics of it, and in terms of being able to fill direct to boats or direct to ships or direct to other utilizations. We have a few types of delivery. They're sort of icons. I can, share with you if you want later of the exact details of the products. But we have, and I'm going to share a bit later in the presentation as well. We have one which is what we call pods. This is the most flexible solution. So we have a truck that will have 10 pods. They contain about 400 kilograms of hydrogen, compressed at 450 bar. And on the truck, which you can't see in the logo, there's a crane, so we can actually deposit these pods and pick up the empty ones for refilling. Of course, there's tube trailer distribution, but it's in a unique truck where we have a truck with a partner that's going to be trucked with a distribution facility. As I mentioned with 450 bar, this was specifically for small day boats and for other solutions. There's the Hinava yacht, which I think you've seen. It's a 13-meter day boat. And with that, we can actually be compressing to 450 bar, delivering direct to truck and ports. We did a sort of mock-up situation of the truck because we didn't have the new version available last summer on our summer tour, and we're able to refill the boat in 5 different ports along the Côte d'Azur. So that allows us to go into a location and go directly into a boat, a truck, or a trailer through compression filling. And then we have containers. A 40-foot container is about 1 ton of hydrogen, and a 20-foot's about half of that, 500 kilograms. With the containers are interesting is we'll be using those when we're dockside for producing energy, because with 1 container, that's a Corsica ferries for 6 hours dockside when we're actually up to scale and producing 1 megawatt of power dockside. So I'm going to jump forward to a bit of the pod solution because we think it's really unique. Calvera is leading that. We're hearing of other Toyota now is coming up with some pod solutions that I'm hearing about, and we have other solutions on the market. So, we're not going to be producing, but we're buying off the shelf things that have been done. Calvera was the leader in this, but it's really innovative in the ability for us to be able to drop off pods that could be refueling forklifts. It could be dropping a pod locally. And I think if you've seen the joint venture between Hivia and Plug Power, they're doing light trucks. Those are also used in France as ambulances and first security vehicles for fire. So those are things where we could drop off a pod locally at an ambulance, a hospital, a center, or a fire station, and they could be filling locally. It's also pods where we can drop behind generators and be generating electricity. So I'm coming up to my 15 minutes, and the timing's great, so we can leave this to a lot of questions. This is something that we're really excited about because I think it's the first phase where we're going to get a lot of use of hydrogen without complexity, which is generating hydrogen to energy, generating instant remote power without any infrastructure. So the way that it goes is we produce the green hydrogen, as I mentioned, at Sunrhyse. We compress it up to 450 bar. We'll distribute it in containers or pods, and we put it behind electrical generators. We're working with Energy Observer Developments. They're one of the leaders in the space, have some great generators, and you can sort of put them together for scaling up from 100 kilowatts up to 1 megawatt of power. And the ability to do that is we can do some really innovative things with this generation. As I mentioned, we can generate for the cruise ships and ferries while they're in ships, which is green power, but it also not putting off the pollution in the ports where we want. We can use it for supercharging boats. So as much as I'd love to be having more hydrogen boats on the water, it's slow development. There are now electric boats and various solutions for electric ferries, but they're going to need superchargers, and the docks and the facilities can't provide that. We can be providing hydrogen and literally being able to recharge these boats anywhere we want. The same thing happens for cars. For events and locations, even in the ports where cars are coming in, they don't have the ability of the infrastructure to do 70 kilowatt Tesla superchargers for electric cars or electric trucks or electric vehicles. We can be doing the same thing. I haven't put it in the logo on the graphic, but we would simply add, connect the Energy Observer generators or electrical generators, hydrogen, directly to cabling for powering light trucks or cars and being able to do supercharging. And again, this is also remote power for events. We've done this last year and we'll continue to do it for Sail GP, for the Monaco Energy Boat Race, for any remote event that wants to have green power. We can do that, and by delivering the hydrogen and providing the power behind that. It's really efficient. It's cost effective now, especially with the increase in diesel fuel. It's 100% green. It involves security perimeters, but no infrastructure to be put in place. And we can do that anywhere in our delivery range. What it also provides for is we don't need to be refilling another object, so we need no compression. And we can actually use all of the, basically almost all of the hydrogen in our tanks and our pods or our tanks, because the generators can function down to 30 bar. So I'm going to cut it off there at exactly 15 minutes. And I'm not sure how audio-wise, Pao, you can figure this out where I can talk or answer, but we can figure out, put this off to 5 minute or whatever timing you have for questions and answers.
you, Marc, for a very nice presentation. So as he mentioned, basically, Marc will need to leave in the next couple of minutes, so he won't be able to stay until the end for the Q&A. So if there is any questions for Marc at this moment, we have a couple of minutes from the audience here or from online. I don't know if there is anything in the chat. Any question for Marc from the audience? Or from the chat? Maybe
Well,
I can have one question, Marc.
Sure.
It's related to the feasibility of the project that we are doing in the south of France. You mentioned that it is 800 kilos of hydrogen per day that you'll be producing. Is this a demonstration project or is it a commercial project already?
Sure. Can you hear me? Okay. Yeah, we changed it. It started with 800, but we're actually having more demand. So we're actually going right to 2 tons a day initially with our production facility. No, it is not a demonstration project. It's a commercial project. At 2 tons a day, we're actually economically viable. We're having hydrogen that's coming out of our plant at 5 to 6 euro, with 3 euro of delivery costs is what we're estimating. And at 9 euros at the pump, so to speak, it's actually quite economical and it is profitable for all the players involved. So to be really clear, we move beyond the demonstration facility. It's a production facility. We can make it work economically at 2 tons a day with those pricing of 6 euros coming off of the factory and 9 euros delivered to the client. So what's great about that, we do have some subsidies from the government to help make that work in terms of our investment and our clients. But at that economics, it actually works on an operating basis. So the subsidies just help on a CapEx in terms of making the returns a little bit more interesting. We're looking at this remotely. To give an example, that is done in France, where energy costs are at 12, 13 cents per kilowatt, and diesel generators and so on. We were looking at places where, like Corsica or various different islands, in the summer it actually peaks at 42 cents a kilowatt hour, which they're doing on diesel generation. So, we're actually on the limit of being economically feasible in the south of France with very competitive electricity costs. If we start to go to the islands like Martinique or other places where they're spending 40 to 50 cents, and that was 40 to 50 cents in September, prices on generating electricity via diesel, we can actually believe we can be cost effective at that rate. So the smallest is, we look at 2 tons a day is pretty much, I think you could go down to 1 ton a day. It makes it difficult to be economically viable, but which was our objective. I think we talked about this last year, of 1 ton a day would be the ideal, but at 2 tons a day, we can become economically viable. And I think in places where they're more remote and costs are even higher, we could bring that number down to 1 ton a day, be competitive locally, and be profitable as a production site. So we're looking to be able to roll that out, the same kind of ecosystem with our learning in various different places with that kind of volumes. But you can get quite quickly to 2 tons a day in an ecosystem if you're doing ferries coming in dockside, as an example, or wintering. We get there quite quickly, a lot faster than light mobility, which is sort of 3 kilograms per vehicle. Okay, just one last point. If there are any other questions that come up, please share my email, and whatever, more than happy to either get on a call with Zoom from anyone from the conference, or share other information or specifics on documents via email to anyone at the conference.
Very good. Thanks a lot, Marc.
Thank you for your time.